Let's review the survey option. Once we've seen everything about the setup, let's go to the Survey menu point Survey, and we'll quickly talk about the interface of this function. At the top we can see the angular values: horizontal angle, vertical angle, inclined distance, horizontal distance. What we had already reviewed regarding the configuration of the compensator or electronic bubble, general settings, the selection of the type of target without prism, target prism, and everything that has to do with the measurement. Towards the left, we can see the option for point information, point name, and code selection. We can also see the information for northeast and height for each of the points that we are measuring. Towards the right, we can see the toolbar, where we can quickly see the configuration of the information bar, where we see northeast and height. We could also get, for example, the vertical, horizontal, and inclined distance. And we could display more information towards the bottom. Also in the toolbar we have different functions where we could take out, for example, if we want to measure the distance between two points, perimeter and area among others. We simply select it, send it to the left, and say OK. And here we see that it appears, for example, the measurement of perimeter and area. We can also have the visualization tools zoom in, zoom out, and the base map settings. Now, let's configure it. I can work with an online base layer. We have, for example, Google Vector Maps or raster maps satellite images. And we could also import a background layer. Click Add and I could import a ship file, a raster file in TIFF, JPG format, or even a CML. Okay, this is to serve as a guide and background information for our work. I'm going to select a vector map from Google. And having the station connected to the internet so that it can obtain the information. We can see our location, nearby roads, buildings, etc. on the map. Then we could switch to raster, for example. And there we see how it quickly regenerates the satellite image information of the site where we are working. Logically, this is because the georeferencing of the points goes hand in hand with the configured projection. What does this mean? We cannot expect, if we are working with arbitrary coordinates, that the base layer is in the correct place. We must be working with cartographic projections, with reference ellipses, so that there is a match between the information that is being displayed and the information that we are handling. We also have the option to quickly change what would be the CAD module. We will see this in videos or in the next videos, and we are going to take a series of measurements. I'm going to put PT1, for example here PT1, and I can assign a code. In this case, I'm going to measure without a prism. The reflector height is set to 0, and you can always switch to a different reflector type if you need to, here in this upper part. In this case, I can use the laser pointer to guide myself. I'm going to turn on the laser pointer, and I'm going to make a series of measurements, where in the lower part, I see that I have the option to measure. It's only going to show me the values. We need to click Save to save the data. M and S would be to measure and save, and it keeps all your data fully intact. I'm going to measure and save it directly. There it is. Next, I'm going to make a series of measurements. After measurement, I could get closer and see how those points are looking. PT1, PT2, PT3, PT4. Obviously, the satellite image needs a certain zoom to be displayed. So I'm going to change it to a vector map so that we can see more easily where the points are located and where I can review the information of the points that are being saved. In the point library, here I can see each of its coordinates. I can see PT3, for example, edit it, and see the coordinates that were measured there, and I can also edit its code. And here, we are also seeing the information of the horizontal and vertical angle and the different distances obtained. In this way, we can perform a quick measurement through point measurement. In the point measurement option, we also have an interface where it directly shows us the data obtained in those cases where it is not necessary to have the plan view. We can perform the measurement and directly have the distances, coordinates, angular values in quickly. I can assign a code and name to the point. For example, I'm going to put L1. And below have different options. We click Measure and save to measure point L1. And click Data. We can change to the Shapes or Graphical interface, where we can now see all the extended tools of the point measurement function. See you in the next video.